Good afternoon, everyone present. Welcome back to the AICTE ATAL online faculty development program organized by the Department of Chemical Engineering, Amal Jyoti College of Engineering. As we reach towards the final day of this engaging series of discussions on climate change and its impact on environment, we are privileged to have two distinguished speakers to lead our sessions today. Our first session will be on the topic climate change and fragile state of Earth's ice systems. Without any further ado, to introduce and welcome our first speaker, I kindly invite Professor Dr. David K. Daniel. Please, sir.
Yeah, thank you, Blessy. Am I audible?
Yes, sir, you are.
Yes. Okay. It's my pleasure to introduce Dr. C.C. Bashir, who is a senior scientist and in the ICCS, and he has obtained his master's in science in physical oceanography from Cochin University of Science and Technology. And apart from that, he was awarded the prestigious MEXT scholarship from the Ministry of Education, Culture, Sports, Science and Technology, Japan, to pursue a PhD in Japan. And subsequently, followed by that, he earned his PhD from Hokkaido University, Japan in September 2013. Dr. Bajish continued his postdoctoral studies at York University, Canada, and before joining the Kerala State Council for Science and Technology, ICCS, he worked as a project scientist, grade 2, at the National Center for Polar and Ocean Research, which is abbreviated as NCPOR. Throughout his academic and professional journey, Dr. Bajish has actively participated in diverse array of research, developmental and exploration projects with focus on elucidating the dynamic interactions between the ocean atmosphere and the sea ice. His doctoral research has marked a significant milestone in his career, delving deeply into the complex natural climate interactions surrounding Antarctica. Utilizing satellite remote sensing data and coupled global circulation model simulations driven solely by natural forcings, he has gained valuable insights into the long-term variation in sea ice and its pivotal drivers in this region. Building upon this foundation, Dr. Bajish's current research at the Institute for Climate Change Studies in Kottayam is centered on investing the regional scale implications of climate change, particularly in southern India. Employing advanced high resolution regional coupled models, his goal is to discern the impacts of climate change on the local environment and the society. I personally welcome Dr. Bajish, and we are very much happy to have you with such vast experience in an area where we really want to learn more from you. Over to you, sir, Dr. Bajish. Thank you very much.
Thanks for the nice introduction, Dr. Daniel. Okay, let me just go to the slide. So is my slide full screen now?
No, sir,
No.
it is. We can still see the
No.
full.
Okay, maybe again. Is it still, it's not in presentation mode?
It is not yet in presentation mode, sir. We can still see the full screen.
What do you see? Do you see the slides?
Yes, the slides are visible, but the whole screen is there. It's not in presentation mode.
Oh, really? Okay, somehow. So maybe I'll share again, maybe. Now? Can you see my full slide presentation?
No, sir.
So maybe how to. Okay, I'll try to share my entire screen. And okay. How about now?
Yes, sir. Now it is in
Yeah, it is
presentation mode.
okay. It is okay.
Okay, okay. Sorry for the delay, actually. Okay. Good afternoon, all, and welcome to this lecture. So I think you all had an interesting sessions before these sessions. So now basically I think I'm going to a different topic than usual that you have been used to. So my topic is about climate change and also the uh, state of our Earth systems. So in my talk, basically, I'll be focusing mainly on the polar region. But when we take the ice systems in the Earth, in our Earth, basically we can take the two poles, Arctic, Antarctic, and there are also these high mountains like Himalaya, where the ice caps are present. Like in different continents, we have different uh, um, ice on very high mountains, and they are very much the source of drinking water to a lot of population in the valleys and the plainlands. But here I'll be mostly focusing on the polar region, especially. So this is the overview. So mainly, I'll just do some introduction and also look at some like outline about how the climate change is impacting the ice systems, mainly Arctic, Antarctic, and how they interact uh, at different time scales. And if time permits, I'll just talk about some work that we did. So when we talk about Earth system actually, so there are different components to our Earth system. So we all know about that. And the main thing, spheres that is involved is atmosphere, hydrosphere. Then we have this cryosphere, which is what I'm going to focus in this. So cryosphere is made up of, it is just the frozen state of water that is present, and it interacts in a different way with our Earth system, different spheres. So, and it is also very much important aspect. But the focus, since it is in the remote areas, so it is very difficult to access most of the cryosphere areas. So, in the past, from the past and to the present, we had issues with data because of the accessibility. But recently, we have a lot of information thanks to the remote sensing techniques and new techniques that have emerged, so that we get some understanding. But still, there is a lack of insights in this area. So it is a really very important area that we all can pursue on. So the basic thing about our climate, we talk about the sun, the solar radiation that is coming in. So that is the only source of energy that is the main source, and it is partitioned into different ways. So the incoming solar radiation reflects out, and it is also absorbed by the land, water, and it is reflected back, and the long wave radiation is absorbed by the carbon dioxide or greenhouse gases, which heats up the uh, earth. So basically, it is a need because of the greenhouse warming only we have the optimum temperature to live in. Otherwise, Earth's black body radiation would have been like we will be in minus degrees. So this optimum heat is due to the greenhouse radiation. But what we talk about the climate change is the global warming, that is mainly due to the anthropogenic effects. So coming to like talking about the natural variability. So if this is a ice core data, from Antarctica. So ice, when we talk about polar ice, so it is also an repository for the past climate variation. So our paleo climate scientists, they drill the ice cores and look into how the temperature and other aspects, how the atmosphere varied in the past. So this is an ice core data which goes back to almost 8 lakh years. So we can see that there is variation, natural variation between temperature and carbon dioxide. So they fluctuate, like the atmospheric temperature fluctuates almost with the fluctuation proportionally with the carbon dioxide changes, even in the past. So in the recent, we are in kind of a warming period where we can see that it is the temperature is increasing. So coming to the natural causes. So these are the some like the changes in the orbital movement of Earth around the sun. So we get a variability within 20,000 to 1 lakh years. And there is also energy coming from sun, which might vary, which can have the natural variability in the climate. Also, in the past, we had very big volcanic eruptions that have big influence on our Earth climate. But when we come to the recent time, so this is very much updated global average temperature. So this it came as a news in BBC. So we always IPCC is always talking about a global temperature of 1.5 degree centigrade threshold. So they are all so curbing the emission so that we can keep the global temperature in this way. But in 2024, it has we can see that with respect to the industrial or other global temperature anomaly has gone beyond 1.5 degree centigrade. Maybe there might be some uncertainties involved in that, but yeah, we are in the temperature is showing a clear sign of increase. And if you look at the recent carbon dioxide level, so with respect to the 8 lakh kilometer past data, we have gone very high. So our carbon dioxide in the atmosphere is in a record level. So how do we know that whether this is a natural variability or and just not a natural? So whether it is anthropogenic. So we don't have any mechanism to exactly make the measurements, but we do have some mathematical computational models, which is now we have these Earth system models, which gives us the climate projections. So in this, we can clearly see that in the graph that when we have the natural forcing that is in blue, it is following a path which is almost nearly going without much change around zeros. But when you look at the observation, it matches with the anthropogenic forcing. So that clearly shows that we are in a phase that most of our climate is driven by the activity of ourselves, the human being. So anthropogenic climate change is very much real. So this is just to again tell that how the carbon dioxide, this is a very long data that is on the right side, we can see the carbon dioxide emission data that is being seen, and we have a very high carbon dioxide since 1960s because of industrialization, automobiles, and all the activities that we have done. So that when we talk about the climate indicators, so there are different aspects of climate indicators that is very much important. The changes of that will reflect on the like with the climate change. These indicators are very important. So when we look at, there are almost 7 climate indicators that IPCC and have put forward. So in that we can see cryosphere as one of the main component of the climate. Within that, glaciers, Arctic and Antarctic sea ice extent, these all come in. So which I'll discuss in my talk. Then there is also the causes that due to these things, because of the interaction with the cryosphere, the other aspects also will be affected. Like, for example, sea level, which directly has an impact through the changes in the cryosphere. Okay. So, as I mentioned, that I am just focusing on our polar region instead of high mountain region, which Himalayas and all. So here, what is the main like this? On the top, we can see the Arctic, the North Pole, and the down we can see Antarctica. So, what are the differences that we see? So, Arctic is an ocean surrounded by land. So, so that will have a different kind of interaction and a different kind of climate. And when we look at Antarctica, it is a continent at the center, and around that there is an ocean. So so these kind of different like phases of our like water and land. So water within a land and land around water. So these kind of things have a different kind of interaction. So we can see, I'll explain it in my coming slides. So what are the key components when we talk about the ice system? So what I earlier mentioned, like sea ice is important. Then there are glaciers. Glaciers mainly it is focused on the, like we can see on the mountains. Mountain ranges. Then there are ice sheets. Ice sheets are nothing but large masses of ice over the land. So, for example, Greenland has a large ice sheets. And permafrost. Permafrost is nothing but it's a frozen ground. So those are formed like during and after the ice ages, and it has been frozen for a long time. So, and why this is important, like around polar region contains around 69% of world glacier area, and most of the fresh water is stored in this region. Also, when we talk about the temperature, the movement of temperature. So polar region is important because it's covered by ice, snow, and all these things are white in color. So basically what happens here is that they have a very high albedo, which is nothing but the reflectance of the surface. So when so it absorbs very less solar radiation, so it modulates the temperature in that region. So when compared to ocean has a very low albedo, and it absorbs the heat coming in and it warms up. So these kind of changes in the nature of interaction with heat makes it important for the global climate. And otherwise, yeah, 75% of water, and it also is important for global oceanic circulation. So ocean is also important player when we come to climate, because it regulates a lot of things in our whole Earth system. So this cryosphere plays an important role in the circulation of the ocean. Then, yeah, one of the important features of the cryosphere that I mentioned. So what is known by sea ice? Sea ice is nothing but frozen water there are different phases of sea ice that I have shown in the figure. So as we know, like it is not an even surface. We have like very much uneven. So that also plays an important role when it interacts with the atmosphere and the ocean down below. So it interacts with both atmosphere on the up and ocean down below. So yeah, in ocean it makes very due to the sea ice formation, there is a production of bottom waters, and it helps the thermohaline circulation, and it also regulates the heat that is coming from ocean to atmosphere, atmosphere to ocean. So in this way, sea ice is very much a regulator of the climate. So when sea ice is reduced, we will have a feel of the change in the climate happening around. And there are different sea ice has a like seasonal change, like it when it comes to the winter it increases, and during summer when the temperature increases it melts. So it has a seasonal change. Also there are sea ice that survives different seasons, so it is called multi-year ice. So yeah, these are the some interaction that happened. So with locally how it interacts. So basically it interacts with the wind, and as I mentioned, the ocean and atmosphere. So okay, this I mentioned already about the insulation effect and the circulation, how the sea ice is affecting the circulation. And so sea ice is also like sea ice as well as other forms of cryosphere. So basically sea ice is a boundary between ocean and the land. So that's why it is very much important for a lot of ecosystems and upper animals in the food chain. So if you look at since it's a margin between ocean and ice, lot of hunting, it is hunting ground for polar bears. They live around that. Also in Antarctica, penguins live on sea ice. They feed, they make their young ones on the sea ice basically. And the seals are also have like their own habitat in sea ice. So all these living beings are affected when the sea ice is gone, and there is a change in that environment. So and also if you look at the food web, when we look at the primary production, the lower tropics, so those things also, sea ice is mainly, it's a breeding ground for a lot of algae. I'll show you in the later. So and there are a lot of nutrients trapped in the sea ice. So when the seasonal cycle happens in the sea ice, it affects it. It increases productivity, and there are a lot of life happening in the ocean. So in that way, it is also a region where there are a lot of uh, life going on. So we can see that whales are seen near sea ice because of krills which feed on the algae that grows on sea ice. So in that way, like it is very much connected to the ecosystem in the region. So any changes in the system will affect all this biogeochemical and also the human. So this is just for fun. This is we know that India also has Antarctica stations. So this is expedition that does the observations of sea ice. So some photo. But okay, this is some interesting photo that I'm just, this is below the sea ice. So we can see that it is not plain white. We can see a lot of algal growth happening. So as I mentioned, it is hunting ground for a lot of organisms around. So we'll below sea ice, we'll see a lot of activities with a lot of fishes and like that. So if this is how it looks like. So these are all living organisms below the sea ice. Okay, so coming to the climate change aspect, when we talk about climate change and how it impacts the ice system. So especially I'm looking, as I mentioned, I'll talk about Arctic and Antarctica. So, so what are the changes? So basically, what we talk about, okay, we have only one energy aspect. So the what we talk about is global warming. So with respect to that, there is a uh, 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 differential changes at different areas. So if you can look at CIs, okay, there will be like when the temperature increases, what will happen? So CIs is a process. CIs is produced because of the, okay, one important aspect when we think about polar region, the temperature, the maximum temperature will be in single digits, that too in pure summer. And when we go back, like it is like polar region is mainly energy deficient. So we have 6 months of sunlight and 6 months of winter without any sunlight. So in that way, we have to think. So not in a way that we think about our like how the Kerala weather is. So when this goes below zero, when the temperature goes below zero, uh, naturally water freezes. So in case of ocean, it is we have to go sea ice is formed minus 1.9 centigrades. So when there is an increase in warming, the sea ice formation time becomes delayed, and as well as it melts faster. So in that, the seasonal cycle is being broken. So that is one of the aspect. And if you look at the ice sheets, they are nothing but the accumulation of snow. So we have, like in the winter, there are a lot of precipitation and it accumulates. Over time, it accumulates and it goes over season, years, and all these things. So, so the what happens when the temperature increases? There are chances for precipitation in water form. So that water is a change in the state, and it absorbs a lot of solar radiation. So this in this way it can affect. So, and when the temperature increases, the melting can happen. So that is what we can see. And the frozen ground, what I mentioned, permafrost, when temperature is increased, these all things mostly happen during summer. So the temperature gets warmed, the frozen ground can become a little bit disoriented. So in this, but these all things have greater impact to the Earth system as a whole. So, okay, coming to just some introduction. Okay, we can see that there are different. I have put an okay table. Table shows uh, the extent of sea ice, the maximum and minimum. So in Arctic, there are like when we talk about poles, there is different seasons. So actually in Antarctica, the summer is sorry, in Arctic the summer is mainly in September. So that's when the ice is less, but the maximum ice is in March. But in Antarctica, the maximum ice is in September, and a minimum ice extent is in uh, February. So we have to think in that terms when we talk about these ice systems. And so since Antarctica is covered by land in a confined ocean, its ice is confined big boundary with the land. But if you look at Antarctica, the ice grows around the ocean, and it is confined by the ocean changes, the temperature in the ocean and the boundaries in the ocean. So Antarctica sea ice like expands almost double of its size during the September, like the maximum ice is found in September. So, so that is that vast amount of ice has a insulating effect all over the water mass that is the Southern Ocean. And we can see that, okay, in the graph in the right side. So it shows how the it's a time series about how the global sea ice has changed. We can clearly see in the top, we can see that that the global sea ice is nothing but the sum of Antarctica and Arctic sea ice. So we can see a decreasing trend. And but the change that we can see more is happening after 2015-16. So that is marked in the blue box that I have shown here. So, but the one of the peculiarity is Arctic sea ice is always having a decreasing trend. That is shown in the green. So it has been decreasing consistently. So this data is from satellite actually. So we are talking mostly after 1979 because that is where the satellite era has begun. So we will get a consistent observations during these periods. And when we look at the Antarctic sea ice, peculiarly it was increasing until 2016. Then we can see a drastic reduction, which I marked in that what you call red arrow. So these are some of the changes. Okay, Arctic has been more it was more affected by the global climate change than the Antarctic. So those are some changes that we can see. So this is a report that has recently been but by NOAA. So what is the state of Arctic? So this is a good thing. We can go into that. It talks about the whole thing collectively. Coming to the main point, like what are the changes that happens in Antarctica? When we look at Antarctica, Arctic, that this graph clearly shows the main difference. So this is the surface air temperature plot from 1900s to 2020. So the gray curve shows that the global average, and the green line shows the Arctic average. So clearly after maybe 2010s, we can see that the Arctic temperature has overtaken the global mean. So that shows that in the recent past, the Arctic has warmed very much, around twofold than the global mean. So, and with respect to that, since in the previous slide, there is a consistent increase in the mean temperature. We can see that it is being reflected in the sea ice extent. So sea ice extent shows a consistent decline around 12% per decade, that much decline in sea ice. And if you look at the ocean, SST also, the ocean is also getting warmed. So so this as such, like when the sea ice has reduced much, there is a kind of feedback mechanism that is playing inside. As I mentioned, this ice plays a role that insulates the temperature between the atmosphere and ocean. But once ocean is exposed, the atmosphere temperature, the ocean is getting warmer. So when it absorbs a lot of atmospheric heat, then the main thing is like ocean captures the heat and it has much residence time. So with respect to that residence time, it has the memory of that heat. So then we'll have a feedback mechanism. So when it warms up, it will gradually have a positive feedback where the ice, once ice is reduced, the positive feedback works in, then we'll have a reduced ice. So in Arctic, what we find is like the temperature is increasing, sea ice is reducing, and then simultaneously the SST is also increasing. So and that memory is captured by the ocean, which keeps the sea ice very much low. So this is mainly called Arctic amplification because it is one of the fastest warming area. So the one of the important thing is like since it's surrounded by many countries, Arctic is surrounded by many countries, it is very much geopolitically very vibrant, and there are a lot of issues and also a lot of discussions about Arctic sea ice. And we can see that this change is impacting the countries around that. both in positive and negative ways. Positive means there is like, okay, there are a lot of oil wells around this region, which like Bering region around the coast of Norway, Russia. All these countries have a lot of oil rigs, and once sea ice is reduced, it will be easier. The harshness will go away. So for them, so economically they will get a better chance. But then the transportation, like Arctic is a shortest route. So once sea ice is gone, there will be a short route for ships for transshipments. But otherwise, then there is a issue that we'll get uh, uh, the issues of changes in the biodiversity in this region, as well as the permafrost getting melted, and we'll get like the methane gas is being emitted, increasing a positive feedback to the warming conditions. So more heat waves, also extreme weathers because of the cycle of some more heat and more energy and more cooling. So so this is just what I had mentioned, like yeah, Arctic has twice warmed, and it has declined very much, and Arctic amplification is happening. So this is how the sea ice looks like. This is a ship that is going to the North Pole, and you can see that the interesting way, like you have sea ice, and top of that there is melt. Those are called melt ponds. So what happens in the white areas, sunlight is reflected, but wherever that water is there, small ponds, what happens, it absorbs the heat, and naturally that temperature of water increases on top of ice, and it makes a positive feedback loop, and the ice is naturally melted away and gradually gone. So this is how it happens. So once water is coming into play, ice's effect is gone. So different state. So this is another okay. This is another important aspect: Greenland ice sheets. So Greenland, it is the what is the difference? Like sea ice is on land, on the water, so it is the volume is taken from the water, and it once it melts, it is given back to the water. But Greenland, on the Greenland, it is on the land, so it is accumulating. It is not. It is from due to the hydrological cycle. We get precipitation, and so water from the ocean or other sources is accumulated on the ice sheet, so it grows. So that is mainly where the all fresh water is stored. So this directly impacts the sea level. So we have to be concerned about, although like sea ice is important, and it modulates. So for this, it modulates the weather around that region. So it gives for positive feedback for changes happening on the ice sheet. So everything is interconnected, but this directly supplies to the sea level rise. So so when we look at okay, so Greenland, okay, as I mentioned in the top, like it has all the Greenland ice when it melts. So we will get around 7.4 meters of global sea level rise. So that much water is stored in Greenland, and it has been consistently experiencing net loss annually. I'll show it. And it is also the second largest contributor to ocean like sea level rise. And the recent this thing is around 5.55 gigaton of mass in 2024 has been lost since 2013. So this picture also shows the positive feedback. Once a pond is formed on top of the ice sheet, it will erode the top of the ice. So these all things can cause instability to the ice sheet. Mainly, ice sheet works on its gravity, its mass. So once there is some kind of intrusion between, due to the water intrudes, it can break because of the less frictions and the lubrication effect of water. Okay, so this is what I mentioned. So the Greenland ice mass has been reducing in the past decade. Um, and a lot of when we talk about ice or a glacier, at the coldest point, we will have a lot of accumulation of snow, and with respect, it moves due to its own weight. So at the weakest point, that is around the boundaries, it moves due to the gravity, and it goes out. So that is called the discharge. So basically, we can see the discharge at the edges of the ice sheet. So we can see that the discharge is also, because of the warming environment, there is also a discharge which is consistently increasing from 92 onwards. So yeah, we can see that there is a consistent reduction in the ice sheet in the Greenland, and there is systematically there will be an increase in sea level. So as I mentioned, okay, this is from the report of 2023. So we can see that wherever the anomaly is red, there is a high melt rate, and wherever that blue is there, so regionally and intra-annually there can be changes, but what we should be concerned is about the trend. So trend has been increasing, so more discharge is happening. So melt days also is increasing at some region, and it is also it might be due to the local weather variability. What are differences are here. So another important aspect of our Arctic region is the permafrost. In Arctic region, lot of permafrost areas are now exposed to the environment, because Arctic is also warming. So we have this okay, lot of, so permafrost is nothing but it is frozen ground which has been there since the ice age. So what happens, they have trapped lot of, like it's like petroleum, and this lot of carbon materials has been trapped underneath of this. And once the stability of permafrost is gone, when it warms, it can, like water can come in and it can break, a lot of instability can happen on the ground. So that can increase, it can help the methane gas to escape. So methane is one of the largest source of greenhouse. So it is, it will be positively impacting the our warming. And another thing that is recently happening is that the region, polar region, is getting greener in a sense that once the warm environment is creeping in, so the boundary is coming inside, so a lot of alien means warmer plants and shrubs can come inside to the Arctic region, Arctic circle. So it is those kind of activities happening, and those kind of animals that depend on this kind of vegetation also are coming in. But due to the weather, like a warm and dry weather, a lot of fire is also happening in tundra vegetation, which is so Arctic was earlier a sink of Arctic Ocean, and the region around that was a sink of CO2, but now it is changing into the source of CO2 and also methane. So this is a concern for us. So how we can mitigate these things is also a question we have to think about. So so this was about Arctic, and coming to Antarctica. So we can talk about, okay, these are some key sea ice variables. Okay, one more thing that I didn't mention is that there are also in Arctic there is snow on land. So we all know, we do when we go to the north region in the cold countries, there is snowfall. So this snow also is very much important. It controls the environment. So there is researchers have seen that the land snow is also diminishing in the around the Arctic land region, which I didn't add. So maybe that is also a thing we can think about. And when we come to Antarctica, so as I mentioned, Antarctica is covered, a landmass covered by sea ice. So there are different key variables that we look at sea ice research. Okay, this figure that shows a satellite image. It is how like our technology has improved. We can clearly, this is a remote sensing image from Sentinel-1 satellite, and there is a ship that has been trapped. That is from Indian. It is a cargo vessel that goes to Indian station, which was trapped in the sea ice, and we can clearly see how resolution has changed. That we can clearly see that ship has been trapped in the sea ice. It's just for fun. So I just shared this one. So okay, coming to sea ice in Antarctica. So there is, I mentioned, there is always a seasonal and interannual changes. Since I did my work mostly in Antarctic sea, so I have more authentic figures in this one. So we can see that there is a seasonality. So the blue curve in the left corner figure shows the winter sea ice extent, and so you can clearly see the sea ice grows and then it diminishes. The red curve shows the summer sea ice. So that much changes is happening in sea ice, and there is a seasonality around regional variability is also there. And the time series shows that the sea ice extent was increasing until 2015, and then it suddenly changed. So in Arctic, the sea ice was continuously decreasing, but here it was like, okay, it was gradually increasing, and this had a debate. Like there was a debate whether Antarctica is really not affected by the global warming. So now that things have changed a bit, but still there is a debate. But but there are signals that the warming signals are really coming in. So this is a figure that shows that okay, in the top figure it shows the sea ice. Okay, sea ice ranked with the lowest. So we can see that within the magenta box, recently almost every record lows are in the past decade. And similarly, when we talk about the warming, temperature, we can see that almost every warming event has happened in the recent decades. So same kind of signal we can see like when we look at the time series annual. And so we can tell that, okay, recent past decade has been very warm for Antarctica as well. So since, okay, as I mentioned, okay, since Antarctica is covered ocean around land, it has a different way of its wind structure are different, and there is the circulation is different. We have a circumpolar Antarctic circumpolar current around the Antarctic continent. It's the current that goes around, and similarly we have circular currents around the circular wind around the Antarctica. So these and with respect to the continents, in the different 3 continents are there around Antarctica. So with respect to the land, sea, temperature differences, the wind pattern also changes, and those things affect the sea ice as well as the ice sheet in the region. So when we talk about, okay, this is a spatial pattern. So this shows nothing but the recent changes. Okay, we can see that red color is prominent most of the time. So this is a seasonal figure, like summer, from summer to summer, autumn, winter, and spring. So the top it is the air temperature, and the bottom it is the water mixed layer temperature. So we can see that there is a warming happening both in the air and as well as in the ocean. But the one thing we have to take care of is, okay, although this is very much red, it won't be going above 0. So those things, once it goes above 0, then our threshold is broken. Like so for time being, a lot of things are stable. Once it goes above 0, then we'll have a lot. So that happens only during summer season. So we'll have positive temperatures. So seasonality is also we have to take. But what we have, what we what is the takeout message is, it is consistently having a trend. So what happens that once things accumulate, at some point it can break. So that is the takeout message. So when we look at okay, the ice sheet. So this Antarctic ice sheet is very much larger than Greenland ice sheet. So once all of Antarctic ice sheet melts, we'll get a sea level rise of more than 120 meters, around 100 to that much amount of ice is there in this large continent. So there is maybe some risk, like where this red color is being shown is the edge. It's called East Antarctica, no, West Antarctica. So there are some kind of maybe instability is there, like, because we can see that there is a lot of ice mass changes. But when we look at the west, that main continent, there is not much changes. But only in the edges we can see that red and dark color, which is losing ice mass. So even in Antarctica, we can see even though sea ice was increasing, but due to the reduction in these areas, there is a large decrease in ice mass. So around 142 gigaton of ice per year is being lost in Antarctica. So okay, that amounts to 0.4 millimeter of sea level as well. So that is also an important thing we have to take care. And Antarctica has, okay, with respect to like this is it's called ice shelves. Ice shelves is nothing but the ice sheet that is floating on the ocean. So here so that is also there is a lot of equilibrium, which okay, there are, I don't know, I don't have pointers, but there are some areas where the ice floats on the ocean. So those ice are very much susceptible to breakage or other activity. But when sea ice is there, it forms a barrier. But what happens when the ocean gets warmer, it can like carve into the ice. When it is warmer than threshold, it can carve into ice, and it can break. It can make what you call it can make it unstable and can form calving and breakage. So a lot of icebergs can be formed in this region. So that can make changes in the environment a lot. So this is also one point of concern that is happening in Antarctica. So these are the regions where ice shelves are there. So this is a Nature paper, I think. So this shows the rate of how much ice is being lost during this period. So what are the implications when we talk about all these things? Okay, what are the implications with ice sheets and sea ice loss? What will be the implication in the ocean and atmospheric interaction? So ocean, as I told, it is also an important climatic parameter. It's what is the importance of ocean is it takes away a lot of carbon dioxide. A lot of carbon dioxide is being stored in this. So it is a sink to carbon dioxide. As research shows, lot of our global warming was curbed due to the ocean. But now what happens once the ocean is getting warmed, then it changes now the sink has been gone to like source. So once there is no source, sink to carbon dioxide emission. So in that way, ocean is very much important in the climate modulation, and it distributes the heat. So the thermohaline circulation is very much important, even though it is very slow. So there is one term called this conveyor belt. It is a large scale circulation in the ocean, and so Atlantic is an important part of that. So there is a circulation called Atlantic meridional overturning circulation. So that is where this blue arrow is there. So once a warm saline water reaches there, it becomes cold and it sinks. So that drives the ocean climate. But recent warming in Arctic region creates a lot of meltwater from the Greenland, which what happens changes the buoyancy in the ocean. So we'll have a lot of fresh water in that region. So because of the buoyant nature of the water, it won't sink even though it becomes cold. So that weakens the Atlantic meridional overturning circulation. So then that can have a lot of implications. I'll show in the next slide. And another point of concern is that that is also with respect to ocean only. We have a lot of bottom water. These are related to ocean climate. So ocean is not very static. We don't have a static ocean. It is continuously moving, and signals from one region is being propagated. So in the surface it moves very fast, but when it goes down, it is moved. It is a density driven current. So mainly these changes in the polar region, it affects the density driven current. So the down current might not, if it becomes static, what will happen, we don't know. There are a lot of gaps. We haven't explored the ocean as such, but there are a lot of gaps in this thing. So this is one of the what will happen when this Antarctic meridional overturning circulation stops. So it can affect a lot of things, our Indian monsoon is also affected, the African monsoon, Amazon. So it is kind of a tipping element for a lot of our climate drivers. Okay, another thing what I mentioned is Antarctic bottom water. So it is also a current that originates from Antarctic continent. So it is mainly driven by the formation of sea ice. So sea ice forms. So what happens once sea ice forms, lot of salinity is being ejected, and the water temperature is very cold. So once this high saline water is getting cold, salty water, it sinks because of its density is being increased. So it forms the Antarctic bottom water, and it is so dense that it flows to the continental slope and to the down. It makes a current that moves very slowly in the bottom of the ocean. So once this stops, what will happen, we don't know. So even though it won't, it will be in the time scales of very much years, not in maybe our lifetime, but these are all the concerns that we'll have when the polar region equilibrium changes. And there is another term called teleconnections. Teleconnections is nothing but it is a remote connection, remote forcing that happens between the maybe atmospheric pathway, between upper atmosphere or stratospheric pathway. How maybe the one of the very much famous teleconnection is ENSO. So we always tell, okay, last 2023 was very much warmer in Kerala or India. So that was due to El Nino. So that is a teleconnection that is happening to our weather. So in that way, this Arctic sea ice changes has a teleconnection to our extreme rainfalls in the central India during summer monsoons. So some other works have discussed how the change in the sea ice in the Antarctica also affects the monsoon, because we talk about monsoon because for India monsoon is a very big entity. So it brings a lot of water, and our people strive due to monsoon. So this kind of research shows that okay, something happens in the pole, maybe can have some impact even in our weather systems too. So in that way, these things are very much important. Okay, I still have some time. So this is okay. This is not about climate. I'm not talking about the climate aspect, but this is an impact, or maybe we can tell okay, a uh, small scale event that is happening due to the climate change. So this is a discussion about a paper like last 2023 CIs was record winter. Winter means we have large sea ice in Antarctica. So Weddell Sea is nothing but a part of Antarctica. So what happened that there was a large reduction in sea ice. So this is a paper that discuss okay what happened during that period. So even though it is not driven by the large scale forcing, but yeah, we can see that okay, there are the changes that is happening in ocean, that accumulated changes happening in ocean, and atmosphere is driving some changes in the ice, and that too in even in winter. Winter is very cold period, but we can see that there are some changes. So these are some figures, the seasonal cycle of the sea ice extent, and we can see that 2023 is standing out, and it is standing out beyond the second standard deviation. So something peculiar is happening during this time period. It's not just a climate scale, but I'm just telling. So and in different areas of sea ice, there is a different changes is happening. So we can see that this blue line is showing okay, there is a reduced sea ice during that the maximum sea ice period. So why is this happening? So that was a question that we tried to answer. So that was mainly like during this, as I mentioned, okay, due to the constant changes, we have we can clearly see there is an accumulation of heat in the ocean. So in that way, there is like, okay, we can see that there is a positive anomaly in the upper ocean as well as at some depths. So there is a heat accumulation. So this kind of change is driving driving, or it is preconditioning the sea ice, what you call sea ice growth, and the time period is very getting delayed. And there is also changes in atmosphere happening due to these things. There is also, because of the heat transport, there is a increase in the low pressure activity. So this is a permanent low pressure area around the Antarctica, so that is being deepened, and due to that we get intense wind. So in Southern Ocean is the ocean around Antarctica. It is very famous for its storminess. It is because of the change in the water temperatures and the gradient. So there is a lot of instability happening in this region. And once pardon? Okay. Okay, was it not addressed to me? Okay. Okay. So there is a lot of changes in the wind pattern. So we get the pressure. These are the pressure patterns that is being that drives the winds. So there is a deepening of the pressures, and wherever the high pressures are there, it is also getting more strengthened. So these changes in wind, it is nothing but there are a lot of storm activities. So because of the warming happening in the oceans, there are a lot of storms. Storm means, although even though it is very much stormier region, it is getting intensified. So there is there is term called explosive cyclones. That is nothing but the intensification of cyclones within a time period. So there are a lot of explosive cyclones that is happening. So this is nothing but I'm just showing there are a lot of storms that is happening during this time period. So these are usual thing, but it gets more unusual because of its intensification. So due to this, like there is a wind forcing, and there is change in the ocean. So these things exemplifies a lot of things. Like there is changes in the sea ice is not very much. It always dynamic. There is, due to storms, there is a movement of sea ice, and also storms bring a lot of heat inside. And the one of the peculiar thing we can see that is a zero line. Zero, as I mentioned, okay, once the temperature goes above zero, then we'll get, okay, there is some energy coming in. Before that, in polar region, we should not think about okay, instability. But once these things can happen, heat comes in, there is accumulation, and if temperature goes beyond zero, it causes something. So what we see is, okay, there is these systems bring a lot of heat, and the heat means the source of heat is from the north. So it brings a lot of water vapor and heat inside the region where the sea ice is there. So that along with the mechanical changes, there is thermodynamic changes that can reduce the sea ice. So this there is a series of storms happening which reduce the sea ice in winter. Winter, you see, it should not be that much. It will be like no sunlight is there. So in that time we are getting a reduction. So this is what it is happening. So if you, this is an animation that the below you can see that is surface air temperature, and we can see the dashed line, that is a zero. So it will, we can see that that storm and the water vapor, it brings the heat inside the sea ice region. So that kind of activities can extreme activities can intensify. So this is the polar region, but it can happen in anywhere, even our region also. When there is a lot of energy is there to consume, we can get such kind of activities that can change the environment. So so this is just one of the work that we did recently. So that's why I'm just showing that. But it also highlights, okay, what can be the change. So when these things adds up, so these kind of things adds up, we will get different, like the trend will be a different thing, and accumulation can happen. So this is how the ice changed, and on a specific day. And this is, if you put it into a perspective, it is this change in ice is almost as large as United Kingdom. That much area of ice has been changed due to that cyclonic activity. So this can add up and make changes. So this is what it is a paper that we wrote about the storm activities and how the winter sea ice was. That is, this was an extreme event. If you look at, so this is a record low sea ice. So what are the things that contributed to this one change? So these kind of things can happen when when there is a change in the structure or the environment in the polar region. So now I'm coming to the last part. This is, I'm not going much into this. So when we talk about modeling, okay, there is so we talk about a lot of things. When Antarctic ice will be zero, so such kind of articles you might have seen, like Arctic will be ice zero in blah 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 2050, all these things. So these things comes from modeling results. So mostly when we talk about the polar region, Arctic is somewhat better represented. Confidence level is much more better than in Antarctic. So this is some like projections that is being shown. So when we in a different scenarios. How so? All the projections shows that our okay, global temperature will be increasing in 2100 the next century, until like we can, if we reduce our emissions. So this is what it is around the globe, and we can clearly see that the Arctic region has more. So this is called Arctic amplification. So that is exemplified. Um, so that is very really concerning. We have to think about that. But in projections, Antarctica is not so much warmed. So that is also a gap. So there are a lot of things that has not been explained in this modeling thing. So how the hydrological cycle is changing. So and how the ocean is. So we can clearly see that there is a lot of upper ocean warming, and especially the Arctic Ocean is also warming during this period. And yeah, we can see that, okay, these are the projections. Okay, what I was mentioning about when Arctic sea ice can be zero or almost, so practically ice free. When we have this 5 to 8.5 RCP, around 2050, it might be zero. So, but other things like it is only extreme cases in this century, Arctic can be ice zero. But yeah, we have to, these things we have to take into confidence. But it shows, okay, it follows the same trend. So once we make a linear trend, we can see that Arctic can be zero, but it can have its own implications. So ocean acidification is also increasing. That is, we can also see from observations. And the mean sea level, the projections are showing, but it is like within 1 meter, even if we go. So it is not very drastic. It is not because it is because of the ice sheet, which are more stable than the sea ice. So as a summary, I can tell like polar regions are very much critical. Whatever we have discussed, it is critical for everyone. The climate as such, because it has very much lot of climate parameters involved in polar region. It affects the transport of heat from one region to another. So there are some things which are being pushed to its threshold. Not everything. Like there is alarming situations, but yeah, there are some things which are alarming. So we have to think about that and how to mitigate those things and the impact. So there are a lot of things which are unclear, like ocean as such is also a black, it's a dark area. We don't know much about oceans, and that too, when we come to this polar region, it is very harsh environment, and we don't have remote sensing equipments that go down. So yeah, it still needs to be explored. So there are some things which are unclear. Even some other aspects are also might be there. So what will be the way forward? So it should be like, okay, it is not a, okay, maybe geopolitical or other thing. It should be more, the work should be more collaborative and also innovative. We should find some innovative technologies so that we can get more data, so that we can understand the system very much better. Thank you. So thanks. I think maybe I'm within time.
Thank you, sir. Now, can we open up for a Q&A session? Sir, can we take some questions from the participants? If somebody is trying to speak, you're not currently audible. Ma'am, actually, we can't hear you. So can you kindly post the question in the chat box? Ma'am, it is still muffled voice. We can't hear you.
Okay. Yeah, yeah, of course.
Ma'am, can you try using the chat box for posting the question?
Okay, of course. Yeah.
Am I audible?
Yes, sir, you're audible.
Yeah. In the meantime, let me ask one basic question which is not very clear to me. I just wanted to know, sir, what is the difference between the glacier and an ice sheet? Is it clear?
Yeah. Glacier, both are same only, but glaciers are mostly on mountains. So on top of like mountains, we call it as a glacier. So it is also the principle of both the things are same, but ice sheets are nothing but it's on land. It even contains, it is in the polar region with the which is on the land, on the over the continent or Greenland. So these are very large masses. And so in Himalaya, we don't call it as ice sheets because those are glaciers. It's uh, on so the mechanism of both of them are similar, but
Yeah.
in polar.
Yeah, but my doubt is in polar regions, is Antarctica and all, we have ice sheets or glaciers? We have glaciers, right?
No, those are on land. It is called ice sheets.
Okay.
Yeah, and when it is on top of water, it is called ice shelves. So it moves similar to glaciers. It moves with respect to its gravity and wherever it can flow with respect to its own gravity. It moves, but glaciers we don't call ice sheets on Himalayas. Mostly
Okay.
all the mountain fed things are called glaciers.
Okay.
That
Now my concern was because of this global warming, we always talk about. In fact, we also teach that glaciers are melting and the water level is going up and all those things. So my concern is these. Let us say that we take say 100 kg of a glacier and 100 kg of an ice sheet. The amount of water which is going to melt and come out from that, is it going to be the same or different?
Yeah, it is. I told you the both are same, except
Okay.
we are just telling like on Greenland we tell ice sheets, and
Okay.
on Antarctica, we tell ice sheets, but when we come to a small mountain, like nearby mountains, we talk about glaciers. And there are like, the basically the thing, like mainly both of them are similar. Like you have snowfall and they accumulate. So so the density, everything should be similar. So you can even mention it as glaciers. No issues for that. As far as I am concerned.
Okay. So, thank you.
Yeah.
Thank you, sir. Do we have any more questions? So seems like there are no questions and there aren't any questions posted in the chat box too. We will move to the conclusion. I kindly invite Professor Dr. Suraj sir to deliver the vote of thanks.
So thank you, sir. I want to sincerely thank our distinguished speaker, Dr. C.C. Bajish, for the enlightening and motivating talk today. We have gained a deeper grasp of climate change and fragile state of its ice systems thanks to your knowledge and captivating presentation. Your commitment to knowledge advancement and your readiness to impart your insightful expertise have greatly influenced all of us. We sincerely appreciate all of your time and work in preparing and presenting such an in-depth and stimulating presentation. Thank you once again, sir. And with a token of gratitude, Department of Chemical Engineering, Amal Jyoti College of Engineering, sharing a virtual memento with you, sir. Thank you. Thank you so much, sir.
Okay. Thank you very much.
Yeah, thank you, sir.